All right, this is Chapter 2, Lesson 1, Finding Square Roots and Comparing Real Numbers. All right, we have a warm-up exercise just to kind of get us into the groove of what square numbers are. A square room has a side length of 25 feet. What is its area? So think of the formula for area. Normally we do length times width, but this is a square room, so we could do side squared. Area equals side squared. Okay, you plug that in, plug that side in, and you get 625 feet squared because 25 times 25, or 25 squared, is 625 feet squared. So just kind of get us warmed up. But let's actually talk about what square roots are. So on your notes, you have some places to fill in blanks. So a square root of a number. If b squared equals a, then b is a square root of a. Now that sounds kind of confusing when you're dealing with letters. So let's put some numbers in there to kind of see what those letters represent and what that means. An example would be if 3 squared equals 9. Well, in this case right here, the 3 is representing the b, and the 9 is representing the a, because 3 squared equals 9. 3 times 3 is 9. Kind of makes sense. And also, negative 3 squared is 9. So negative 3 times negative 3 equals 9. So therefore 3 and negative 3 are square roots of 9. They are the numbers that multiply to themselves to make 9. Okay? All positive real numbers have 2 square roots. All of them. Only positive real numbers have 2 square roots. They have a positive square root or the principal square root, and they have a negative square root. Okay, as of above. So 3 up here would be the positive or principal square root, and this would be the negative square root, because negative 3 times negative 3 is 9. And a square root is written with a radical symbol. The radical symbol is this symbol right here. That's the radical. So the square root of 9 is written like that, and the square root of 9 is positive or negative 3, or positive and negative 3, however you want to look at that. Okay? All right, so moving on to the first example, evaluating the expression. All right, so this is asking us for the positive and negative square root of 36. Well, since positive 6 times 6 is 36, and negative 6 times negative 6 is 36, these are both the square roots of 36, the positive and negative square root of 36. So just fill those in the blank, positive 6, negative 6. Okay, for number 2, or excuse me, letter B, the square root of 49. Now, since I don't have this symbol out front of that square root or that radical sign, I want the positive square root. Okay, the positive square root of 49 is just 7. If you want the positive and negative, generally you put it out front, or you look at it and see that it's positive and negative. If they don't have that, sometimes, not always, sometimes you can assume they just want the positive square root of 49. Not always. We'll talk about that later. And then example C, the negative is now out front. So that means we want the negative square root of 4, which would be negative 2, because the negative square root of 4 is negative 2. Okay? All right. Sorry about this random radical on the page, but I'm going to go ahead and give you a problem at a time, and the answer is going to come up. So if you need to pause the video after you see the problem, pause it. So I'm going to go through fairly quickly. Problem, answer, problem, answer. So if you need to pause between each problem, then there you go. So the negative square root of 9, negative 3. Number 2, guided practice. The square root of 25, positive 5. Number 3, the positive and negative square root of 64 would be positive and negative 8. And the last one, negative square root of 81. So therefore it would be negative 9. Okay, if you have questions about that, bring those to class. Okay, our next example, example 2, approximating or estimating a square root. We're going to show you a couple things about estimating. I'm going to show you a couple things about estimating. But the first thing you need to understand are the perfect squares, those numbers that have perfect square roots. So I didn't put 1 in here, but we could include 1, because 1 times 1 is 1, so 1 is also a perfect square. These numbers you see on this bottom row are your perfect squares because 1 times 1 is 1, 2 times 2 is 4, or 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on to infinity. You can square any number and get a perfect square. Now these are your perfect squares. If you take the square root of 16, it has a nice even number of positive or negative 4. Same thing with the square root of 25, positive or negative 5. Okay, so we're going to approximate or estimate the square root of 28. Well, 28 is not a perfect square. It falls in between these because there's lots of numbers in between these perfect squares that don't come out nice and even when you take the square root. So find the two perfect squares that 28 falls between. So 28 would fall right about here in between 25 and 36, closer to 25 than 36, but in between the two perfect squares. Okay? So we're going to write a compound inequality that just compares them. Just compare them. 25 is less than 28, and 28 is less than 36. Just showing that 28 is between these two values. All right, then we're going to take the square root of all three numbers. Okay, so take the positive square root of each number. So we have the square root of 25, and it's less than the square root of 28, and it's less than the square root of 36. Okay, so now we're going to actually take the square root of the two perfect squares, and we're going to get an answer of 5 and 6 on those outsides. Now, so what it's telling us is the square root of 28 falls somewhere between 5 and 6. So it would be 5 point something. Okay, it's an irrational number, but it's between 5 and 6. 5 point something, something, something. Okay? Now, here's where it gets confusing. I've got this on the paper, but I want you to use my note. Okay? I've got this on your notes, but this is where I really want you to pay attention to. The average of 5 and 6 is 5.5, and 5.5 squared is 30.25. That's a lot of math, and occasionally you might have to use it, but because 28 is less than 30.25, square root of 28 is closer to 5 and 6. However, I have a very easy way to do this. Since 28 is closer to 25 than it is to 36, that would be another way to know that the square root of 28 would also be closer to 5 than to 6. Okay, the square root of 28 is going to be closer to 5. So it's about 5. The square root of 28 is about 5, or you could say a little more than 5, because 28 is a little more than 25. A little more than 5. So there's your options for approximating. So you find two perfect squares that your number falls between, take the square root of those perfect squares, and your number is going to fall, or your square root is going to fall between those perfect squares. So we're going to do some guided practice on this, and I want you to pause the video after each problem and find your answers. Okay, so we're going to approximate to the nearest integer. I do not want exact answers. I want whole numbers. So the nearest integer. Okay, so the square root of 32. Pause the video and find which perfect square is 32 closest to, and then work through the square roots, and then play the video. Alright, the square root of 32 is closest to 6, because 32 is closer to the square root of 36, or excuse me, 32 is closer to 36 than it is to the perfect square 25. Okay, when we take the square root of these, obviously the square root of 25 is 5, and the square root of 36 is 6. So again, our square root of 32 falls somewhere between the 5 and the 6. But because 32 is closer to 36, the square root of 32 is also closer to 6. Okay? All right, next problem. The square root of 103. And you should have estimated 10, because the square root of 100 is 10, and 103 is very close to 100. All right, negative 48. Okay, you should have estimated it to be negative 7. This 49 is a perfect square. 48 is very close to 49. So the square root of 48 would be very close to 7. And in this case, negative 7 because the negative is out front. And here's the last one. It's a little bit of a challenge. I'm going to let you pause the video, kind of see if you can figure that out. And you should have figured negative 19. Okay? 350 is between the 19 squared and 20 squared, but it must be a little bit closer to 19 squared. Okay. All right, moving on. The square root of a whole number that is not a perfect square is an example of an irrational number. Okay? An irrational number is a number that cannot be written as a fraction. Okay? So, on your paper, it says write some examples from the PowerPoint on the diagram. So let's talk about some whole numbers, okay? Whole numbers are things like 0, 1, 2, 3, ... All the positive non-fraction numbers, okay? Integers include whole numbers plus the negatives. So negative 1, negative 2, negative 3, ... Still no fractions. Okay, so whole numbers are the positives, integers are the positives and negatives. Rational numbers are things like fractions, 1/3, negative 2/9, decimal point 18 repeating, 0.25. All of these are rational numbers, and all of these numbers can be written as a fraction. Okay? Every one of these numbers can be written as a fraction. An example of an irrational number that you guys probably are most familiar with is pi. Pi is irrational. Irrational numbers. Here's the definition. Decimals that never end and never repeat. They cannot be written as a fraction. They never end and never repeat. So pi is an example of that. But the square root of a number that is not a perfect square. So the square root of 2. Perfect example of an irrational number. Over here, we could put the square root of 4 because this is a perfect square. It equals 2. So it would be considered an integer and a whole number. Over here, the square root of 5 is not a perfect square, so this would be an irrational number. It's a decimal that would never end and never repeat. So the square root of a whole number will be a decimal that never ends and never repeats. So there's just some examples of real numbers and the difference in those square roots. These we just leave in the radical sign, the square root of 2. We just leave them that way because there's no nice, neat number to give for that answer. Okay? All right, so let's classify some numbers. I think on the back of your notes you have a chart, and we're going to talk about these numbers. Okay, so let's talk about it. Tell whether each of the following numbers is a real number, a rational number, irrational number, an integer, or a whole number. Okay, first of all, we're going to think of real. If you look back at your chart on your notes, real numbers are all the numbers we're going to deal with in algebra. Okay, so every number we deal with in Algebra 1 will be real. Now the next column you have is rational and irrational. A number cannot be both. It is either rational or it is irrational. Can't be both. Okay? It can be an integer and it can be a whole number. Rational and irrational are the only ones that both of these, that they can't be under the category. So let me just kind of explain what we're doing. So, for example, the square root of 24. Yes, it's definitely real. Okay? It's not rational because it's not a perfect square, so it is irrational. It's either a yes, no on this column. One of these columns has to be yes, one of these columns has to be no. They can't be both. Okay, since it's not rational, it cannot be an integer and it cannot be a whole number. So if you have yes in this box, you have got to have no in these boxes. If you'll look at your graphic organizer, Okay, if it's irrational, it's not even in the same circle with the integers and the whole numbers. Okay, all right, the square root of 100, well, that's a perfect square. It equals 10, so it's definitely real. It's definitely rational because 10 is rational. It cannot be irrational because it is rational. And it definitely is an integer. It's 10. And it's a whole number because it's positive. Integers, remember, can be positive or negatives, no fractions. Whole numbers are only the positive numbers with no fractions. All right, the negative square root of 81. Again, 81 is a perfect square. So it's a negative 9 is the answer. It is real. Yes, negative 9 is real. It's rational because it can be written as a fraction. It's a nice number. So it cannot be irrational because it's rational. It's an integer because it's a negative number with no fraction. But it's not a whole number because it's negative. Okay, I know that's kind of confusing as a box of rocks probably, but, or confusing as mud. I don't know how you say it. So it's your turn. Oh, we were going to do some other numbers on the notes. Just leave your notes blank. We might do some numbers when you come back to class. Okay, we might do 2 or 3 others to kind of explain because I know that's confusing. So bring that chart and we'll do 2 or 3 other numbers in that chart. All right, example 4. Graph and order real numbers. Order the numbers from least to greatest. Well, you can graph the numbers on a number line. Obviously, our negatives are going to be the furthest to the left, and our positives will be further to the right. So here's our number line. You have it on your paper, and it just shows you. Again, we're estimating the negative square root of 5. You guys, you can put that in the calculator, and you can get part of the decimal. Since it's never ending, you can't get the whole decimal, but you can get part of a decimal and compare it. Okay, so we have a comparison. So negative 2.5 is smaller than negative 2.24. And then we have 1 1/3, and then the square root of 9 is 3, and then the square root of 13 is about 3.61. So you can use calculators. I'm fine with that. So here we are from least to greatest. Negative 2.5, negative square root of 5, positive 4/3, square root of 9, square root of 13. So if you want to, use your calculators to estimate these square roots if they're not perfect squares. Notice the squiggly lines, these little equal signs that look like this. This means, I'm going to make it equals, estimate or approximate. So an estimate or approximate. So pause the video, do some guided practice. And then the bottom part of your notes, the conditional statements, we're going to talk about those in class. So you don't have, there's no more video for the bottom part of these notes. So once you pause this video and then try your problem, I'll give you the answer and then you can stop. You're done with the notes. All right, there's your answer. I hope you may have used the number line to help you if you needed to, but there's your answer from least to greatest. You can estimate these on your calculator or in your head, however you want to do it. Okay, and leave the bottom half of your notes for class. All right, I will see you Tuesday.